to our video on the fascinating topic of sound and resonance. To start things off, let's dive into our attention-grabbing introduction.
Wow, that was intense! You might be wondering how something as simple as sound waves can have such a powerful effect on objects. Well, that's exactly what we're gonna find in this video.
Let's start by introducing how waves are created. Sound is a form of energy that travels through air, and it's produced by vibration. When an object vibrates, it creates a disturbance in the air particles around it, causing them to move back and forth in a wave-like pattern.
That's right, the sound wave created by an object's vibration has two important characteristics, the frequency and amplitude. The frequency of the sound determines its pitch, or how high or low it sounds. The amplitude, on the other hand, determines its volume, or how loud it is.
Now, let's talk about resonance. Every object has a natural frequency or a specific rate at which it vibrates when disturbed. When an object is exposed to sound waves with a frequency that matches its natural frequency, it starts to vibrate or resonate.
And this is where things get interesting. When an object is exposed to sound waves with enough intensity and frequency, its vibrations then become so strong that it reaches its breaking point and shatters. This is what happened in our introduction with the glass breaking.
So how exactly does sound shatter glass? To understand this, we need to delve a bit deeper into the science behind the phenomenon.
So, when an object resonates, it stores energy in the form of kinetic energy. If the amplitude of the sound is large enough, the energy stored in the object can increase to the point where the object can no more handle the stress, so it breaks.
In the case of glass, the molecules that make it up are tightly packed together, making it a very rigid material. When it is exposed to sound waves with a frequency that matches its own, the vibration caused by the sound become amplified and intense, which caused the glass to shatter.
It's important to note that not all glass shatters in the same way. Different types of glass can have different natural frequencies and require different levels of intensity and frequency to shatter. For example, tempered glass is designed to be stronger and more resistant to shattering, so it requires a much higher level of intensity and frequency to break.
Now that we understand the science behind the phenomenon, let's all explore some experiments and application of resonance and sound.
But first, let's take a look at the video of glass shattering experiment and explain the steps involved.
As you can see, the experiment involves exposing the glass to sound waves with varying intensities and frequencies until it reaches its breaking point and shatters.
This same principle of sound and resonance can be applied in real-life scenarios as well. One example is lithotripsy, a medical procedure used to break up kidney stones. Sound waves are used to create vibrations in the stones, which then break up into smaller pieces that can be more easily passed through the urinary tract.
Another application is in the military. There's a device called the LRAD, Long Range Acoustic Device. It uses sound waves as a non-lethal weapon. It can emit a high-pitched sound that's so intense, and it can cause pain and even nausea in the target.
Another application is in the music industry. Musicians often use a technique called the feedback to create a sustained note by placing either a guitar, whatever instrument they're playing, or their microphone near a speaker. This is essentially using the principle of resonance to create a desired effect.
And finally, understanding the science behind shattering glass can help engineers design better and more durable products. By testing for the natural frequency of materials, they can avoid potential problems that may arise from resonance. So there you have it, the science behind shattering glass with sound waves and its many applications. We hope you enjoyed this video and learned something new today.
Thank you!
Thank you!
Thank
Thank you!
you.
Thank you! Thank you!